Differentiation of parametric equations. Some relationships between two quantities or variables are so complicated that we sometimes introduce a third quantity or variable in order to make things easier to handle. In mathematics, this third quantity is called a parameter. Instead of one equation relating, say, x and y, we have two equations, one relating x with the parameter and one relating y with the parameter. Let us see how the values of x and y change depending on t using the illustration of a Ferris wheel. Parametric equations allow us to make a graph that represents the position of a point on a Ferris wheel. All the details like height of the Ferris wheel off the ground, its direction and speed of its spin, I, can be modeled using parametric equations. How do we find the position equation and graph of a point on a Ferris wheel that starts at a low point of 6 feet off the ground, then spins counterclockwise to a height of 46 feet off the ground before going back down to 6 feet in 60 seconds? To describe this, let's introduce a variable t. The vertical component starts at a low point of 6, travels at a middle point of 26 and then a height of 46 and back down. This is a minus cosine pattern. The amplitude of the minus cosine is 20 and the vertical shift is 26. Lastly, the period is 60. That is, 60 equal to 2 times pi by b implies b equal to pi by 30. Thus, the vertical parameterization is y equal to minus 20 multiplied by cos of pi times t by 30 plus 26. The horizontal parameterization is found by noticing that the x values start at 0, go up to 20, go back to 0, then down to minus 20 and finally back to 0. This is a plus sign pattern with amplitude 20. The period is the same as with the vertical component. Thus, the horizontal parameterization is x equal to 20 multiplied by sine of pi times t by 30. Now, to find the velocity of horizontal and vertical components, need to differentiate the horizontal and vertical parameterizations, and this differentiation is called the parametric differentiation. Method of parametric differentiation. Let x is equal to f1 of t and y is equal to f2 of t are any two functions where t is a parameter. Here, both x and y are functions of t. So, both x and y can be differentiated with respect to t. Then, dy by dx is equal to dy by dt by dx by dt. Find dy by dx if x is equal to a multiplied by theta plus sine theta and y is equal to a multiplied by 1 minus cos theta. So, to find dy by dx, first find dx by d theta and dy by d theta from the given equations. Differentiating x with respect to theta, we get dx by d theta is equal to a multiplied by 1 plus cos theta, and differentiating y with respect to theta, we get dy by d theta is equal to a multiplied by 0 minus of minus sine theta. That is, dy by d theta is equal to a multiplied by sine theta. Now, substituting values of dy by d theta and dx by d theta in dy by dx is equal to dy by d theta by dx by d theta, we get dy by dx is equal to a multiplied by sine theta by a multiplied by 1 plus cos theta. For further simplification, cancel a from numerator and denominator and write sine theta is equal to 2 times sine theta by 2 multiplied by cos theta by 2, and 1 plus cos theta is equal to 2 times cos square theta by 2. Then we have dy by dx is equal to 2 times sine theta by 2 multiplied by cos theta by 2 times cos square theta by 2. By cancelling 2 and cos theta by 2, we get dy by dx is equal to tan theta by 2. Find dy by dx if x is equal to square root of a power sine inverse t and y is equal to square root of a power cos inverse t, where a is greater than 0 and minus 1 is less than t less than 1. One method to find dy by dx is by finding dy by dt, dx by dt, and then by taking the ratio of these two, we get dy by dx. We try this in other way, that is, by eliminating the parameter t. When we observe the given equations and look into the functions sine inverse t plus cos inverse t is equal to pi by 2, so that t gets eliminated. So to get sine inverse t plus cos inverse t term from the given equations, we need to multiply the equations x and y, so that we have x multiplied by is equal to square root of a power sine inverse t plus cos inverse t. Now, substituting sine inverse t plus cos inverse t is equal to pi by 2, we get x multiplied by y is equal to square root a power pi by 2. Now, it is easier to find dy by dx from this equation. So, differentiating the equation with respect to x, we get x times dy by dx plus y times 1 is equal to 0, so that dy by dx is equal to minus of y by x. Observation: parametric differentiation is not always like dy by dt by dx by dt. Sometimes, smartly, we can eliminate the parameter, but this may not be possible in all cases.